So today we're going to be wrapping up, wrapping up the chapter. Tomorrow I'll go over a couple of problems from active, but we are finishing up the chapter for this today. So we're looking at molecular compounds today. Yesterday we looked at empirical. For the most part, empirical and molecular kind of work together. Usually you'll have to solve an empirical problem before you can solve a molecular. And it's just the nature of the way it is. The way we would run this experimentally, we get a sample of a material. We can run it through an analyzer. The analyzer can tell us the percent of each element in the compound. And then it can tell us a molar mass. But what it can't tell us is the actual compound. So, and it's just the way the machine works. So we would have to do the steps mathematically to figure out based off the percentages to get to a formula to get to the molecular formula ultimately. So today we're still going to be doing a little bit with empirical formula, but we're going to be looking more at molecular formula and seeing the difference between the two. So we should be able to calculate the molecular formula of a compound from the molar mass of the molecular formula and the molar mass of the empirical formula. Not yet. We still got two problems on it that we haven't covered yet. All right. All right. So let's look at molecular formulas. All right. So yesterday I gave this in the notes, but I didn't really stay on it too long. But the molecular formula is the actual formula of a molecular compound. So recall from yesterday, that I said the empirical formula CH could represent all of these molecular formulas. All right, so this is an empirical formula, and that's a molecular formula. All right, so a molecular formula tells us what's actually there, whereas an empirical formula tells us what elements are involved in the ratio that those elements are to each other. All right. So we may get an empirical formula that ends up being correct, and that's fine. We may end up getting an empirical formula that ends up being the molecular formula, but that's not always going to be the case. So when we look at the relationship between a compound's empirical formula and its molecular formula, we can kind of write like this. So we have a multiplier times the empirical formula will give us the molecular formula. All right. And so basically we're going to multiply the subscripts across by whatever the multiplier we get is. So the formula for doing this is we will take the molecular formula mass, or the molar mass of the molecular formula, the molar mass of the molecular formula, divided by the molar mass of the empirical formula. All right. So The molecular formula mass will be one of the numbers that's given in the prompt. So you won't have to know that. It's going to be part of the problem that it gives you. All right. So I'm going to break it down by steps like I did yesterday. It's not going to be as complicated, and it'll probably say pretty much the same thing as this, but I'm just going to put it in a different format. So the number that we're going to have to calculate in this is always going to be the empirical formula mass. So once we get the empirical formula, or if we know the empirical formula, we have to get molar mass for the empirical formula. So step one for determining a molar mass, molecular formula, is we can calculate the empirical formula mass, which, remember, that's just like calculating any other molar mass based off of what's there in the compound. All right. Step two is we're going to divide the molecular mass by the empirical formula mass. So that's the little thing that I just gave you, is that our multiplier is the molecular formula mass divided by the empirical formula mass. Remember that that one is given, and this one we have to solve. All right. And then after you get your multiplier, after you get x, you're going to multiply each of the subscripts in the empirical formula by the number calculated in step two, by the multiplier. All right. So again, this is the equation: x, or n, equals molecular formula mass divided by empirical formula mass. And so I'm going to point this out one more time. All right. So the only reason why I'm highlighting those two, that the molecular formula mass is given in the prompt and the empirical formula mass you have to solve for, is because that's the things that get missed the most. I constantly get the question of, where do I get that number from? Well, it's right there. All right. So Does anybody need more time on this?
Start typing. So you do this. X equals, and then you have to go to this.
All right. So let's look at those last two problems on the paper that I gave you that I didn't intend to do in my notes. All right. So the first one is actually an easy problem because we don't have to determine the empirical formula. They give it to us. So when we look at the question, it says an empirical formula of a substance is CH2O. And then it says the molar mass is 180. What is the molecular formula? So the first thing we have to do is be able to look at this problem and figure out what's being told to us. So we know that's the empirical formula. What does this mass represent? Look back at your notes. What did I tell you is given in the prompt? All right, so this is the mass. So the only place I'm going to use that is, remember, it's molecular formula mass divided by empirical formula mass, and that gives us a multiplier. So I'm going to put 180 on top. How do I get my empirical formula mass? I just need to get the molar mass of CHO. So I have 1 times 12.01. I have 2 times 1.01. And I have 1 times 16. So adding those up, oh, sorry, that was me. .01 plus 2.02 plus 16.00 gives us what? So I put 30.03 down here. What do I get from my multiplier? So this is just going to be a whole number because I'm just multiplying it by the subscripts. I can't have a decimal for subscripts. So now I get a multiplier of 6. So what should my molecular formula be? C6, 6 times 2. So it goes to the whole thing. All right. Now, number 5 is a little bit harder because you have to get your empirical formula first, and then you can solve for your molecular formula. Now, let's look at the question. Let's see if there's any unused information and what everything means. So it says a sample that is 3.585 grams contains 1.388 grams of carbon, 0.345 grams of hydrogen, 1.850 grams of oxygen, and its molar mass is 62. What is the molecular formula of this substance? So is there anything in this problem that's not used? Yeah, we don't need this number. All right. These numbers are going to help us get our empirical formula. And what about this number? What does this number represent? That's my molecular formula mass. All right, so take a few minutes and solve for that, and then we will come together and look at it.
Look at it.
All right. So, what molecular formula do we come up with? All right. So I came up with C2H6O2. Does anybody need to see how we got there? Yeah. Okay. So let's walk through it. All right. So the first thing I did was set up for my empirical formula. So I have carbon, hydrogen, and oxygen. I have 1.388 for carbon. I have 0.345 grams for hydrogen, and I have 1.850 grams for oxygen. So that's my mass. For moles, I'm going to divide this by 12.01. So I get 0.1156. For hydrogen, I divide by 1.01. I get 0.342. And for the last one, I divide 1.850 by 16. I get 0.1154 or 1156 as well. Sorry, when I round. So now, when it comes to the ratio, these two are the same and they're actually the smallest amount. So I know that my subscript for carbon was 1 and my subscript for oxygen was 1, and then 0.342 divided by 0.1156 gives me a 3. So that means that my empirical formula... All right, we're going to exit out the back door. So getting back to it, so apparently that one was a drill, but I was not expecting it. So we get the empirical formula of CH3O. Then when we solve for the molar mass of this, I get 31.04 for my empirical formula mass.
Is that an 8 or a 6?
Where? Here? It's a 6. But it really shouldn't matter because there's two are close enough that they're going to be 1 no matter what. All right. Now, so I get an empirical formula mass of 31.04, and I have a molecular formula mass of 62. So 62 by 31. If you want to be ticky about it, We're looking for a whole number multiplier. So I'm going to multiply CH3O by 2, so it becomes C2H6O2. Questions on that? One carbon. One carbon is 12.01. 3 hydrogens. I'm just doing the molar mass.
Oh, it's just molar mass?
Yes.
Oh, you could have just said that.
All right. So we've seen an example of an easy one. The easy ones are fun, are nice because you don't have to do the empirical stuff. It doesn't take as long. When you look at the ones that you have to do empirical formula, they're not hard. They just multiple steps to get there. All right. So try this one on your own. Yes.
It's like, say, like, you get the final thing.
Yes. Say again. That mass is, if you're getting a molecular formula, yeah, you need that number, but you won't need it until the end. Second science. Oh wait, that's flow. Okay, never mind. Oh.
Oh, okay, thanks.
All right. So if we get to this point and we find out our empirical formula is CHO2, we can solve for our empirical formula mass. The molar mass of that is 45.02. In the problem, our molecular formula mass that was given was 90.04. So 90.04 divided by 45.02 gives multiplier 2. So what should my chemical formula be from a molecular formula? 04. You don't understand what?
I added them together. I didn't get that.
12.01, 1.01. I have 2 oxygens. Because it told me. All right. Last two, I want you to work these two out, and then I'm going to show the answers in a minute. I'm going to give about 10 minutes. I'll give 10 minutes or to when I see everybody's done. It's actually worth 10 because it's like times 2. All right. So when we look at this, and that's the wrong one. All right. So again, look at this. You should have gotten H2O2 for number 5. You should have gotten C6H5MgBr for number 10. So molecular formula, again, empirical formula, that's the more difficult part. Molecular formula is just once you get the empirical formula, then you can do a couple extra steps. So going through this, as I was looking at active, I've noticed only about 8 people have even answered questions in active. So chapter 6 active is open at this point. You should be able to answer pretty much all the questions. The only ones that we haven't directly covered are the last 2, and the last 2 are related for density. You're going from volume to mass, and then mass to whatever. All right. So but they'll give you a density in those 2 problems. So those 2 might be a little bit of pause. I might set up one of them tomorrow in class. My intention for tomorrow is to be a work day where we're working on active, where we're working on if you didn't finish the mole concept sheet, things like that, catching up on missing homework assignments. That's my intent for tomorrow. Yeah, you can. Yeah, you can work on it and turn it in tomorrow. All right. So if you did your corrections on yesterday's opening questions, make sure those get turned in. That way I can regrade those and give you credit. The one for today, if you're not totally finished, you can turn it in tomorrow. All right. But you have the remainder of time to work on active or any open assignments today.